Welcome to clickmyproject.com. Let's discuss on the title Bayesian texture classification based on Contourlet transform and BYY harmony learning of Poisson mixtures. Regarding Bayesian texture classification, a newly developed 2D extension of wavelet transform using multi-scale and directional filter banks, the Contourlet transform can effectively capture the intrinsic geometrical structures, which are a key to visual information processing. Because the Contourlet expansion can achieve the optimal approximation rate for piecewise smooth functions with contours in some sense. Recently, the Contourlet transform had been successfully used in content-based texture retrieval, palm print classification, handwritten numerical recognition. So, in this paper, we utilize the Contourlet transform to extract the features of a texture image for the purpose of texture classification. On the other hand, it is very important to design an efficient texture classifier based upon Contourlet features in the transformed domain. From the point of view of statistics, we can consider that each of the Contourlet features extracted from a random image of one texture class is approximately subjected to Poisson mixture distribution. Then Bayesian classifier can be built for texture classification if those Poisson mixtures for all the texture classes can be clarified via some learning algorithm. So in this paper, we follow the transform-based texture classification and propose a novel Bayesian texture classification via BYY harmony learning of Poisson mixtures on the Contourlet features of texture image. Now let's have the discussion on the data flow diagram. Regarding the data flow diagram, you have to select any one of the input images, that is a texture image from Bodak's texture dataset, and you have to extract the features. Here the feature extraction is nothing but Contourlet transform features. Before extracting the features, you can also concentrate on some pre-processing algorithm to enhance the texture quality. After that, for multiple images in the dataset, you have to extract the features and train the classifier. Classifier is nothing but Bayesian classifier, and you have to reduce the dimension of the features using Poisson mixture distribution, and then subject the particular output to BYY harmony algorithm, and the learned part of the algorithm will make you to decide the texture output depending upon the classification. So the texture variety can be determined using this classification block, and further you can analyze the particular texture images with the true labels, and the retrieval accuracy or the classification accuracy can be shown in this analysis block. So let's see the execution of the program. To execute the program, select main_texture.m file and press run file. You will get a dialog box like this. The training set folder will be having different images, different varieties. You can take any one of the texture image and find the category of that. So the results displayed are, this is your input texture that has been selected to predict the category. Second is an enhancement procedure called as histogram equalization in order to enhance the pixel quality. Third one, you are extracting the features, that is you are going to decompose your particular input texture using Contourlet transform, and at each stage you are going to save the output as features. This is a representation of Contourlet transform. Finally, after feature selection, that is dimension reduction and classification, this is a bar chart representing the learned parameters, whether it has been correctly classified or not. Each color symbolizes each variety. We are having 10 varieties in the data set. There is no misclassification in learning. And finally, the test input is being predicted as wood variety, in that the second variety of wood. And the classification, this is the confusion matrix. For each category we are having 40 images. So for 9 categories the diagonal elements are being represented as 40. For the 10th category also it is being represented as 40. And this is the group order followed for classification. These are some metrics that are representing the classifier performance. Your correct rate is 100, error rate is 0, and this is your sensitivity and specificity value. That is the predicted label is 5. The category is wood. So depending upon the execution and the analysis result, we have established a novel kind of Bayesian texture classifier through BYY harmony learning of Poisson mixtures on the Contourlet features of texture images. The Contourlet decomposition sets up an efficient representation of the image for texture classification, whereas BYY harmony learning of Poisson mixtures can lead to a good parameter estimation with adaptive model selection. These two advantages enable the proposed Bayesian texture classifier to be more effective and efficient. The various experiments show that our proposed algorithm improves the texture classification accuracy in comparison with the current state-of-art applications. Thank you.